The James Webb Space Telescope smelled something it was never built to smell. Not perfume, not smoke. Chemicals scar in starlight. A molecule that on Earth shows up when oceans are alive. Serious astronomers called it the strongest hint yet of biological activity beyond the solar system. Other serious astronomers said the claim is not ready. SAMI telescope. SAMI planet. 2 wars over 1 spectrum. That fight is the story, not little green men. Real argument about data from a world you will never visit. 124 light-years away in the constellation Leo. The planet is called K2-18b. It is not Earth. It is bigger and heavier, about 2.6 times Earth's radius and roughly 8.6 times Earth's mass. It orbits a cool red dwarf star in what astronomers call the habitable zone, the range of distances where liquid water could exist on a surface. If the planet has the right kind of surface, that alone would make it interesting. Webb made it explosive. Here is what Webb does that older telescopes could not do as well. When a planet passes in front of its star, a tiny slice of starlight filters through the planet's atmosphere. Molecules in that atmosphere absorb specific wavelength. The spectrum that arrives at Earth carries scars, missing colors that name the gases. That technique is called transmission spectroscopy. It is how you read the weather of a world you will never land on. Earlier Webb observations of K2-18b found methane and carbon dioxide, carbon-based molecules in the atmosphere of a habitable zone exoplanet. That was already historic, and the pattern looked consistent with a strange class of world called a Hycean planet, a hydrogen-rich atmosphere sitting over a deep global ocean, not a rocky Earth twin, not a gas giant. Something in between, an ocean world wrapped in light gases, theoretically capable of hosting microbial life in that ocean if chemistry and energy cooperate. Then came a whisper of something else, dimethyl sulfide. On Earth, DMS is produced mostly by life, especially marine microbes and phytoplankton. It is one of the compounds that helps give the ocean its smell after a storm. Dimethyl disulfide, DMDS, belongs to the same chemical family. Both are treated as candidate biosignatures, molecules that life loves to make and that abiotic chemistry may struggle to produce in large amounts, at least on Earth-like worlds. In 2023 and 2024, hints of DMS in K2-18b's atmosphere sparked headlines and skepticism in the same week. The signal was tentative. It needed a harder look. In 2025, a Cambridge-led team published new constraints using Webb's mid-infrared instrument, MERS. Different instrument, different wavelength range, mid-infrared, roughly 6 to 12 microns, with no overlap with the earlier near-infrared data, an independent line of evidence. They reported chemical fingerprints consistent with DMS, and the statistical significance they quoted sat around 3 sigma. That means roughly a 0.3% chance the pattern is a random fluke. Interesting enough to publish, not strong enough for science to call it a discovery. 5 sigma is the traditional gold standard for claiming something is real in particle physics, and, by cultural inheritance, in many astronomy announcements. To get there on K2-18b, the team estimated they might need something like 16 to 24 more hours of Webb time. Until then, the honest sentence is not, "We found life." It is, "We see something that looks like molecules that life makes on Earth at a confidence level that demands more data." And here is where the story gets sharper and more adult. On Earth, DMS levels in the atmosphere are tiny, often below 1 part per billion. The inferred abundances on K2-18b, if real, would be thousands of times higher, on the order of tens of parts per million. That is not a gentle echo of Earth's ocean. That is a scream. Either something biological is pumping sulfur chemistry at an industrial scale, or something non-biological we do not fully understand is doing the same job, or the spectral fit is wrong. That last possibility matters. Independent groups reanalyzed the same kind of data and argued that the evidence for DMS is much weaker than the headline suggested, that methane and carbon dioxide are robust, but the biosignature claim does not clear a careful statistical bar. Other researchers explored abiotic pathways, ways volcanoes, photochemistry, or ocean atmosphere chemistry might forge sulfur compounds without biology. Laboratory work and theory are still catching up to the claim. So which is it? Hint of life, overinterpreted spectrum, unknown chemistry on a Hycean world. Nobody gets to answer that with a press conference alone. The answer is more observing time, better models, and the willingness to be wrong in public. Think about what that means for you. Sitting here for most of human history, are we alone? Was philosophy. Then it became a radio search, listening for engineered signals. Then it became looking for Earth-sized planets. Now it is looking for molecule, not messages, not ruin molecules. Webb turned the question into spectroscopy. That is both thrilling and dangerous, because molecules lie if you misread them. Oxygen can be a biosignature or a geological accident depending on context. Methane can mean cows or volcanoes. MS on Earth means life. MS on a hydrogen-rich mini-Neptune might mean something we have never seen. 218b forces you to hold two ideas at once. First, this is the closest modern astronomy has come, in public conversation, to saying a living ocean might be within reach of our instrument. Second, science is working exactly as it should, when half the community says, prove it harder. Let me slow down the physics, so the claim does not float away as a vibe. 218b orbits a red dwarf. Red dwarfs are smaller and cooler than the Sun. Habitable zones sit closer in. That means the planet is bathed in a different light environment. More infrared, potentially more stellar flares, more ultraviolet risk for atmospheric chemistry. Hycean atmosphere is thick with hydrogen. Starlight filters through that envelope during transit, and Webb's detectors catch the imprint. Near-infrared instruments like NIRISS and NIRSPEC catch one set of molecular bands. MRI catches another. When both whisper the same sulfur story, confidence rises. When reanalyzers disagree, confidence must fall until the conflict is resolved. The researchers themselves have said the cautious thing out loud. Unknown chemical processes could explain the observation. They want theoretical and experimental work on whether DMS and DMDS can form without life at the levels inferred. That is not a retreat. That is the method. Why does this still matter, even if K218b turns out sterile? Because it proves the pipeline. Finder-temperate sub-Neptune measure carbon chemistry. EST for sulfur biosignatures. RU retest. That pipeline will run on dozens of worlds. Some will be false alarms. None of them might not be. The tipping point is not a single tweet. It is the moment when possible biosignature becomes a routine scientific category instead of science fiction. Imagine standing on a Hycean shoreline. If such a shoreline can exist under a hydrogen sky, the ocean would not look like Earth's blue postcard. The air would not be breathable. The pressure and temperature profile might crush or freeze unfamiliar chemistry, and still, in the dark water, microbes could be exhaling sulfur compounds into a global atmosphere thick enough for a telescope 124 light-years away to notice. That image is speculative. The data is not speculative. The spectrum is real. The interpretation is the battlefield. There is another quiet revolution underneath the headlines. For decades, the search for life leaned hard on Earth twins, rocky planets with thin atmospheres and surface oceans. Hycean worlds expand the hunting grounds. Bigger planets, different atmospheres, scenes that might be deeper than anything on Earth. If life can exist there, the universe just got more crowded with candidates, and more confusing because our Earth-trained biosignature checklist may not transfer cleanly. Webb was built for this kind of confusion. Golden mirrors, cold instruments, infrared eyes that see through dust and catch molecular fingerprints. It was sold to the public with nebulas and galaxies, and those pictures earned their place. But the quiet work, the transit spectra of worlds named like catalog entries, may be how history remembers the telescope as the machine that moved Are We Alone? From prayer to error bars. 3 Sigma is not a trophy, it is a dar. 5 Sigma would still not be a photograph of an alien. It would be a chemical argument so stubborn that abiotic explanations look worse than biology. Even then, confirmation would demand other molecules, other wavelengths, maybe other telescope. Life claims deserve that friction. So where does that leave you tonight? You're live in the 1st century where a space telescope can argue with you about the smell of an ocean on another star. The argument is unfinished. That is the point. Unfinished science is not failure. It is the sound of the frontier, moving. 218b, maybe a sterile Hycean world with weird sulfur chemistry. It may be an ocean teeming with microbes under a hydrogen sky. It may be a lesson in how easy it is to want a miracle in a noisy spectrum. Webb cannot tell you which of those stories is true yet. What it can do, what it already did, is put the question on the table with real numbers, real instruments, and a planet that will not stop transiting because humans disagree. The next observing runs will either strengthen the DMS and DMDS signal or wash it away. Either outcome is a win for clarity, and clarity is how you get from rumor to knowledge. 124 light years is not close in any human sense. No probe you launch today arrives in your lifetime, but light already made the trip. The starlight that grazed K218b's atmosphere is already here, recorded, debated, and waiting for the next photon to tip the scale. That is the secret hiding inside this discovery fight. We are not waiting for aliens to visit. We are learning to read atmospheres at interstellar distance, molecule by molecule, until the universe has fewer places left to hide biology, or fewer excuses left for us to see biology where there is only chemistry. If decades from now people look back and say, "This was when the living universe came within reach," they will not mean a single press release. They will mean a chain of careful, contested infrared measurements that began with worlds like K218b and with a telescope cold enough and sharp enough to smell a planet in the dark. Thank you for watching.